So last class, what we learned was graphing coordinate points, and again, that was completely review. It's not even a part of Algebra 1 curriculum, but you need to know how to graph a point before you can start graphing a line. So we decided to go ahead and just do a review day with that. So just a real quick refresher before we take our Friday quiz, so you guys can do awesome on your quiz. So let's just say we have -2 to 5. I'm going to call this point A. So this is 3, -8. 4, 5, C, and -1, -9. Okay. So remember, the first number is your X. The second number is your Y. And X is this axis here. This is 0. This is 0. We count left to right, however much we need to go. This is my negative side. This is my positive side. So these are X's. And these are the Y's. And again, we start at 0 here. And this is positive Y's. This is negative Y's. So when I go to plot the point here, -2, 5, it's a negative X, so I go left 2, and then positive 5, positive Y, so 1, 2, 3, 4, 5. Bottom one, we'll label that A. Which quadrant? Well, actually, we'll come back to that. Let's just finish quadrant 1, so we'll talk about quadrants. All right, so B was 30, so it's positive 3, so 1, 2, 3, and then -8 down 1, 2, 3, 4, 5, 6, 7, 8. Right there. That's B. C is positive 4, so to the right, 1, 2, 3, 4, and positive 5, up 1, 2, 3, 4, 5. C, and D is -1, that's the last one, and down 9, 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, so our positive negative tells us whether to go left, right, or down, up. And then we just plot a point. So just to refresh, this is quadrant 1, quadrant 2, quadrant 3, quadrant 4. Or if you were to just write it with normal numbers, this is a 1, this is quadrant 2, quadrant 3, and quadrant 4. All right, so we can see point A is in quadrant 2. Bring your ends up. So A is in quadrant 2. We can see that B is in quadrant 4. C is in quadrant 1. And D is in quadrant 3. So you're probably going to be asked that on your mini quizzes. Do you have any questions with that? The only other weird things is if it was possibly on the X or Y axis. So let's say I had the point 0, 3. That means my X is 0, so I don't go left or right. I stay here, I don't go left, right, and then I count up 1, 2, 3. And that would be on my Y axis. That's on the Y axis. All right, and then what if we had the point 3, 0? My X value is 3, so it means I go to the right 3. I don't go up or down at all, so I stay right there, and that will be on my X axis. Questions with that? All right. Yeah, isn't that nice? Not rude at all. Okay, so we're going to go and transition to our mini quiz. So I'm going to go and pass out the different pieces, and then I'll teach you how to assemble it. And then staple it. That's our notes for today. So we actually start off. Go and bring it up here, and I'll sign you next. Right, so that blue one's going to be your top piece. And then next we have purple piece. Next, we have our white piece. And then finally, we have our piece. Okay, so as most of you have probably already figured out, you're going to take your blue piece, that's the top one, and you take your purple and you just insert that underneath the blue flat. So it goes functions, domain, and range, and then vocabulary. And then you're going to take the white piece, insert that in the purple. So we have our next tab, which is it a function from ordered pairs? And then last we have our pink piece. Insert that in. Is it a function from a table? Blue, purple, white, and pink. Okay. So again, it should look like this, where you have blue, purple, white, pink, pink, white, purple, blue. Okay. Anybody need help with that? So next comes the white. There you go. Okay, so this is just another way of kind of presenting our notes. So we'll be going through this. The top one says functions, domain, and range. And then, so that's the title of today's notes. And then we have our vocabulary. What does it mean to be for domain? What does it mean for range, relation, and function? And then next we have our, is it a function from ordered pairs? So we have our notes for that with some examples. Then is it a function from a table? Then looking at a mapping diagram. And then we'll talk about how we can tell if it's a function from a scatter plot, from a graph, and some function notation. Okay. So this is what we're going to be covering today and tomorrow, actually. Or not tomorrow. Monday. We'll be covering most of it today, though. All right. So let's go ahead and take a look at this. Let me assemble this last guy up here. And we'll get started. Okay, so again, these are going to serve as our notes for today. So what we are learning this unit is what it means to be a function and the different things about the function. So we're going to talk about domain and range, which is basically our x values and our y values. What it means to be a function, so when I'm given a graph or a bunch of points or a table, how can I tell if it's a function or not? And then in a couple days we'll talk about our function notation, how to write out a function. So just some of our beginning vocabulary here. So this is again under your blue flat. So on the purple, it says vocabulary. And so domain is just the x values of the input. Just going to turn it into the basket. X values of the input. So it's basically a list of all of our x values. Now, what we had last class is we were plotting the individual points. So we had individual x values. Sometimes, though, we're gonna get to the point where we're graphing a line. It's actually going to be like all of our x values, like 2, 2.1, 2.00001. So it's all of your possible x values. Now your range, that should say, sorry, x values or input, sorry. So input is what we're putting in, so x values are also true. All right, our range are y values or output. So basically what we've had before is earlier in this last unit, we would solve for y. And so we might have had an equation like y equals 2x plus 2.
This one is mine, yes.
So we would solve for y, and this is just an example here, so you don't need to write this down. But basically what we have is, we would take an x value, let's just say x equal to 1, and we would take this and put it in for x. So I would have y equals 2 times 1 plus 3. That was my input, I put it in for x. And then I would simplify, and I would get an output of 5. So what I would know then is that when x equals 1, y equals 5. So this was my input, this was my output. And so on the graph, what that looks like is we would graph the point. X is 1, y is 5. So that's basically what's happening here, is we're going to be taking a look at our x values and y values, see that there's that relationship. Sometimes we can write that relationship as an equation. That's what we'll be focused on mainly, is we have that as an equation. And so we see that relationship between x and y. All the x, y values that make this true, we would graph on our graph, and it actually makes a line. So it's kind of a big connection of where we're going there. So x was our input. We take that and we put it in, and we get out a single value. So we put x in, simplify, we get a number. That's our output, or y value. All right. So next up we have relation. A relation is simply a set of ordered pairs. A set of ordered pairs. Now, ordered pairs are those x, y values. So a relation is anytime we have x's and y's that go together, there's some type of relationship. Now, when it meets a certain criteria, we can call it a function. So a relation is just that there's a relationship between your x's and y's. We did something to x to get our y. Now, our function is for every x, there is one and only one y. For a relation, we just have a series of points. And there are many different, we can have multiple x's, multiple y's. But when we have the relationship where for every x there's only one single y value, then we call that a function. And function is what we work with more in algebra. Okay? So that's your vocabulary. Let's go take a look at how we know if it is a function. Alright. So again, for a function, for every x, I'm going to write this off to the side of your face. For every x, let me try that. There is one and only one y. That's what we defined it as. So for every x, there's only one y. That's what we can refer back to. So now we're just trying to decide, is it a function? And there's different ways it could give us our ordered pairs. They might give them to us in a list like this, a set of ordered pairs. They might give them to us in a table, like you can see on your next slide. They might give them to us in a mapping diagram, which is where they just list the x's, put a oval around it, and list your y's and draw arrows. And they might give it to us in a scatter plot form, right, just a bunch of dots. And then they might give it to us as a graph. So there are a bunch of different ways they can present relations to us. So we're going to take a look at each one and how do we know if it's a function. And again, a function means for every x, there's one and only one y. So actually, before we dive into this, I want you to take a look at your assignment sheet. Go and pull out your assignment sheet. That green assignment sheet that I've been putting homework scores on that we need to do better at doing our homework with. There's something at the bottom there that kind of helps illustrate what it means to be a function. So take a look at the bottom of your assignment sheet. You guys call it a soda machine. I call it a pop machine. Does anyone else call it pop?
That's what they used to say back then.
That's what we used to say back then. So we say in Ohio. Okay. So a pop machine. Down south they call it a Coke machine. I never understood that one because they call all of it Coke. So like if you say Sprite, they say Coke. And then they ask you what kind of Coke. Like I thought Coke was just Coca-Cola. Anyway. So we have the soda pop machine. We'll go with that. And then we have a slot machine. Okay, so our soda pop machine, you put money in, and let's say that you hit the button for Pepsi. You hit the button for Pepsi, and then out comes Pepsi, right? If you hit the button for Crush, does anyone like Crush, the orange pop? Crush or Sun, really? Crush or Sunkist? That's good stuff. Hit the button for Crush, out comes Crush. If I hit the button for Crush, am I also going to get a Dr. Pepper? No. So I hit the button and I get out one single thing. I don't get two different things, right? Now so that would be an example of function. For every button push, if it's a different button, I'm going to get a different item. I can't push the same button and get different things for that same button. Same thing here. For every X, there's only one Y. So for every button, there's only one pop flavor, soda pop flavor. If I push the same X, I'm not going to get a different Y. Okay, so let's just say X is 2. If I put in 2, I'm going to get a single Y value. Let's make it up. Someone give me a number. 6. Okay. If I put in 2, I'm going to get 6. If I put in 2, I'm going to get 6. If I put in 2, I'm going to get 6. If I put in 2, I don't get another number. I don't get something else as well. That's an example of a function. I put in X, I only get one Y. If I were to put in 2, and I get 6, and I also get -6, then that's not a function. Okay? So for every X, there's only one Y. So let's talk about that with the slot machine. Pull down the lever, and you could get this combination of weird-looking guy with glasses, cherry, weird-looking guy with glasses. Pull down the lever again, you can get a completely different combination. Even though you put in a coin, you pull down the lever, you get one combination. Put in a coin, pull down the lever, you're putting the same coin. It can give you a different result. So that's not a function, where if I put in the same value and I get something different, then that's not a function. But if I put in the value and I can only get one response, then that is a function. So a soda pop machine, that's a function. You push the button, you get only one item out of it. You don't get two different items. Slot machine, no matter what coin you put in there, you're going to get different options. So that's what it's going to look like when we're looking at our ordered pairs. So again, we want to make sure the X value goes to only one Y value. Okay, so X goes to only one Y. So we're going to start off by looking at our X values. We want to make sure that the same X doesn't go to two different Y's. So look at your x values. Do they repeat? If they don't repeat, then it's a function. If they don't repeat, then it's a function. That's kind of nice. If my x values don't repeat, then I automatically know it's a function, because that means I don't have it going to a different y value. So let's take a look at our first one here. My x values, so all they did was they listed the ordered pairs. So I'm just going to look at my x values. So I highlight my x values here. Do I see the same number repeating? Nope. So I automatically know it's a function.
What are x's and means?
What's that?
X's are domain.
Yeah, x's are domain. Yeah. Good. So this is a function. Yes, a function. Okay. Now let's take a look at one where they might repeat. Let's take a look at our next one. Does this next one repeat? Let's take a look at our, and again, we're looking just at our x's. Do the x's repeat here?
No.
Nope. So we have this one's also a function. Yes, a function. Alright, how about our last one? I sure hope something repeats.
The 5.
Alright, the 5 repeated. Now, just because it repeats doesn't automatically mean it's not a function. We need to look and see. Our repeaters, or these guys, right? Do they have different y's? If they've got different y's, that's an issue, not a function.
And if they have the same y.
If they have the same y's, then that's okay, because all it's doing is just listing the same point twice.
So it's a function.
Yeah. So you gotta watch out for those weird ones. What if it said, if this said 512 instead of 54, this would still be a function because it's just the same thing repeated twice. They're not different y's, it's the same one. But since they are different y's, oops. Since they are different y's, then it's not a function. Alright. So if they repeat, look at your y values. If they are different, it's not a function. So different, it's not a function.
Could you tell if it's a relation just by looking at the points?
So all of these are actually going to, we'll be always giving you a relation, and then you have to decide from your relation if it's an actual function. So we're going to be giving you relations. There's some type of relationship between these values. You don't have to decide that. We're going to give you relations, and then you decide, okay, is this relation a function, yes or no? So guys, we're giving you the ordered pairs that there's already some type of relationship here. We don't know what the relationship is. That's okay. Sometimes they give you the rule, sometimes not. We're just looking to see, all right, is this relation a function? Okay. So now our domain are the x values, and our range are the y values. So when it asks for domain and range, since I have individual x's and individual y's, I'm just going to list those. And we always want to write these from smallest to largest. So if I look at my x's here, 0, 3, -5, which one's my smallest? Good, -5. What comes next?
0.
0. And then we have 3. And so these are like those squiggle braces. It's taken me about 15 years to master drawing those.
Does it matter if the y values repeat?
Nope. Only if your x values repeat is when we have a concern. So if Eric asked you a good question. If my y values repeat, we don't have to be worried just yet. First, let's do my x's repeat. If my x's don't repeat, you're okay. If your x's repeat and the y's are different, that's when it's not a function. So it's okay if your y's repeat. That doesn't impact whether it's a function. I'm going to look to your x's. All right, so my range are the y values. And I'm going to take a look at my y values here. And again, we want to go smallest to largest. We have 5, 0, and 0. What's smallest? 0. Good. Now, I don't need to list it twice. It's just the same y value. And then next I would have 5. So I have 3 different x values and 2 different y values. We're looking at just the y values, so 5, 0, and 0 for our range. Let's go and take a look at number 2. Again, our x values So I already highlighted them here. Oh, look, they go in order for us. That's nice. 1, 2, 3, 5. Now my Y values. Ooh, conveniently, these also go in order. So I have 4, 5, 6, and you don't have to write the repeats.
What if you did? Doesn't matter.
You're just wasting time, but it's okay. It's not really a big deal. All right. So we do have domains and ranges for when it's not a function. We're still just listing out our x's and y's. Just know it's not a function. All right. So we've got our domain, x values. So we've got 0, 5, 5, 10. So nicely ordered for us, 0, 5, and 10. And then our range, ooh, we've got some crazy numbers here. -1, 12, 4, -1. Which one's my smallest?
-1.
Okay, -1, 4. Okay. So that's when they give us a list of ordered pairs that we can decide if it is a function. All right, so now let's take a look at when they give us a table. All right, guess what? The rules are the same. Look at your look at your x values. Do they repeat? If they don't repeat, then yay, it's a function. So if they don't repeat, it's a function. Woo. Let's take a look at number 1. My x values, hey, no repetition. Yes, it's a function. We've got number 2. Ooh, we've got some repeats here. So again, let's look. If they repeat, look at your y values. If they're different, not a function. So I've got repeats here. Are my y values different? So it's not a function. Number 3, they wrote it a little differently. They said input and output. Which ones are x and which ones are y?
Input's for x.
Input is x, good.
And the Y is output.
Good, y is output. So I need to look. Do I have repeats for my input? Uh-oh. But they're the same. So all they did was listed the same point twice. So it's still a function, no problems. Okay. So once again, let's go and write our domain and range. I like the tables because they always put the x's in order. I should say almost always. So my domain, I just list my x's, 1, 2, 3, 4. And my range, it's not always in order, so you need to be careful with that. 2, 4, and 5. We don't have to write the repeat. Okay. Our domain for number 2, don't need to write the repeats, just have 1, 2, 3. That squiggle didn't go so well. All right, and our range. Oh, it's still in order for us. 5, 7, 8, 9. Right? Our domain, again, that's our input or the x values. Not quite in order here. We have 3, 7. We don't have to write twice, which is 7. 11. And then our range, -1, 4, 12. That sounds familiar. Was that a range from the other one? Okay. I like the table. Any questions on ordered pairs or tables? Okay. So next let's take a look at a mapping diagram. Yeah.
Yeah, every several functions, they ever be any great collection, different functions that it should be.
No, so that's like the defining characteristic. For a function, your x cannot repeat at different y values. It's like big no-no in all of math. And when that happens, it's immediately not a function. It's just not a function. It's defined that way. Good question. All right, raise your hand if you've seen something like this before. A few of us? All right, so this is what we call a mapping diagram. And it's kind of like a table, but instead of, when we have repeats, instead of writing them more than once, they draw arrows. So what you see here is that 2 goes to 1, 4 goes to 3, and 6 goes to 5. Nothing gets repeated there. What I see over here for number 8, 1, 3, and 2, notice they each have 1 arrow coming from it, so those aren't repeated. But if you take a look over here, 8 has 1 arrow, 0 has 2 arrows coming to it, so 0 was actually repeated. It actually occurred twice. But instead of writing it twice, they just drew 2 arrows. And then we take a look at number 9. 5 has just 1 arrow, 3 just has 1 arrow, but 7, notice how there's 2 arrows coming from it? That means it's been repeated. 7 has been done twice. Now it goes to 2 different y values. So my y's weren't repeated, but that 7 was. So instead of writing it multiple times, they just draw arrows to show you how many times it's used. Okay, so looking at a mapping diagram, the first bubble is our x values. Okay, so this is x. This is x. This is x. What do you guys think the second bubble is? Y. Good, our y values. So this is y. This is y. This is y. The arrow shows which x and y values go together. So 2 goes to 1, that means I have the ordered pair 2, 1. 4 goes to 3, I have the ordered pair 4, 3. 6 goes to 5, I have the ordered pair 6, 5. So it's just taking this information and presenting it in a different way. Now remember, you can only have 1 y for every x. Okay? So we don't want x to repeat and have different y's. So we're still pretty much looking for the same thing. For number 7, where my x is repeated, is there more than 1 arrow coming from any of those?
No.
No. So we have it's a function. No repetition means a function. For number 8, taking a look at my x's. Do any of them have more than 1 arrow coming from them? No. So it is a function. It's not repeated. We're just worried if our x's are repeated. We don't worry about the y's, just the x's. All right, number 9. Do I have any of my y or my x's repeated here? Yeah, see how 7 has 2 different arrows coming from it? That means it was used twice, and look, it's going to 2 different y values. So it's not a function. All right, I love writing domain and range for these, because you just list them out. Domain, my x value, so 2, 4, 6. My range are just my y values. 1, 3, 5. Okay. For number 8, my domain, just those x values, but make sure you go in order. What comes first? What is the -3? Good, 1 and 2. What comes first for my range? 0. Okay. Right, number 9, what's my domain? Good, 3, 5, 7. Good, 1, 2, 4, 6 for my range. So again, for a mapping diagram, we're pretty much still looking. Does the x repeat? Just now repeating means look to see if it has more than 1 arrow on the x. Just go write a note there. Repeat means more than 1 arrow. So now let's take a look at a scatter plot. So for these first three that we had, our ordered pairs, our table, and our mapping diagram. They listed the numbers for us, so we just compared our numbers. But our next two are going to be actually on the graph, so we do something a little different there. So our first one we have is a scatter plot. And just a reminder, a scatter plot is a bunch of points scattered around the graph. Alright, so when we have a scatter plot, we must find the ordered pairs for each point. Once we have the ordered pairs, we can use the same rules to decide if it is a function. So again, we're looking to see, does x repeat? And if it repeats, does it have different y's? So does x repeat with different y's? Say y values. So we're going to want to write out our ordered pairs and then just check to see if anything repeated. Alright, so I'm just going to write them off to the side here. Looking at this first point here, I see I went -2, 1. So there's my ordered pair. -2 and then up 1. Alright, let's take a look at this guy. What's that point going to be? -1, 0. Good. We just went 1 to the left. Right? Alright. Let's do this one. So we got 1, 2, so that's +2. 3, good. 1, 2, 3, 4. And that's -2, so 4, -2. And this last one is 1, 2, 3, 4 again. That's 1, 2, 3, 4, 5, -5. Alright, so just list them out. It's a little bit easier to see. Does x repeat? Alright, we've got this potential issue here. Are they different y values? Yeah, different y values. You say, sorry dude, not a function. Oh, oops. Not a function. But it's going to be a lot easier for us to write our domain and range because we've already listed the x and y values. Alright, so my domain, I'm just listing those x values. -2, -1, 2, and 4. Alright, let's list the range, the y values. What's my smallest y value? Yeah, good, -5. Then what's going to come next? -2, 0, 1, 3. Let's take a look at number 2. Again, we're just going to list our points. I just like to go from left to right. You could go bottom, top, whichever you prefer. Just make sure you do all of them. All right, what's my ordered pair here? I heard -5, 1, good. Let's see, let's go this guy next. What's that order?
-3, 4.
-3, -4. Very good, Eric.
And then 0 and 3.
Very good. So we have 0, +3.
Then 2 and 2.
Are any of those negatives or positives?
Oh, 2 and -.
Good. 2, -2. And our last guy here?
4, 2.
Good. 4, 2. Both positive. Again, you can see once you list them out, it's a lot easier to see if x repeated and went to different y values. Alright, is this one a function? Yeah, this one is a function. Yes, a function. Our domain are just listing those x values. -5, -3, 0, 2, -4. their range, just listing the y values. Ooh, it's a little out of order. Let's see. -4. -2, good. 1, good. 2. So scatter plot, we kind of treat the same way. We just we list the ordered pairs and then teach your course. All right, and then the one that I've been waiting for, graph. Wait, no, sorry. All right, the graph is my favorite because we finally get to stop looking at the x values. We're essentially still doing the same thing. It's the easier way to look to see my x values repeat to different y values. All right, for our graphs, notice we're going to have lines on our graphs now, not just single points. And so what that line represents is that I have all these different numbers. So sure, whoops, this dot here, which is -2, 1. But then there's all these little ones in between. So that'd be like -2, -1.99999, -1.9998, and -1.9997, -1.9996. And we would never finish writing out all the points because there's infinite points there. So we're not going to be writing out our different ordered pairs because there are so many of them. This is when we have lines. Let's see these curves here. We instead use what's called the vertical line test.
So if 2 points touch each other, then it's not a function.
Close, very close. So vertical line test. Because we don't just have, it's not the points touch each other, it's that our vertical line hits 2 points at the same time.
You can usually do it with the squiggly one.
Yeah. So we use the vertical line test to decide if a graph is a function. So you can just use your pencil. I'm going to go ahead and actually get out a vertical line here. I'll make mine yellow so it's kind of similar to your pencil there. That's a little bit thicker than I was hoping for. Let's see. All right. So you take your pencil and you just move it from left to right. So we're just going to move it across our graph. And it should only touch the graph once at any point in time. So as I move it across, if it's a function, then it should only hit the graph once. But if it hits it more than once, it's not a function. So here there's not even a graph, no graph, no graph, no graph. All right, it's hitting the graph only at that dot. Good. But as we continue to go, look at that. It's hitting the graph in 2 different spots. Right?
If it does that, it's not a function.
If it does that, not a function. We call that it fails the vertical line test.
But in a test, that line is either.
You're just going to use your pencil. So like you literally just take your pencil and go across and see if it hits it twice at the same time. If it hits it twice at the same time, not a function. So let's fill in the blanks. If we move our pencil from left to right, our pencil should only touch our graph at one place at a time. If it touches more than once, it is not a function. So this is not a function. I'm just going to write it down here. Not a function.
What we can write for domain there?
So that's a good question. So our domain and range for these graphs, we're not listing individual numbers because, again, we have everything in between. You'd be listing them out for the rest of your life until you die. No one wants to do that. You guys want to do other things with your life. So instead, what we're going to take a look at is basically where do our x's start. So my domain is, again, my x's. If I look, when I go from left to right, my graph doesn't even start until right here. What is the x value right there?
-1.
-1, good. So we have it starts at -1, and then if I look, it continues for everything to the right? As I move this along, see how the graph continues for everything to the right? So that means that we have everything greater than or equal to -1. So we actually write this with set builder notation. This is one of the reasons why we learn set builder notation. So we start off with x, because that's what domain is talking about. And again, our x value started, our first point on our graph, going from left to right, was this guy here. And that was the x value of -1. So x is everything bigger or equal to -1. So it started here at -1, and then it's everything to the right, everything bigger than that. So we can look, we have -1, we have 0, we have 1, we have 2, we have 3, we have 4, we have 5, but we also have 1.2, we have 1.9. So we just say everything bigger than or equal to -1. Now when we take a look at our range, we want to, again, we always go from smallest letters, right? So we're going to take a look at range. If I look from my smallest letter, so bottom to top, notice how my graph continues on for forever and ever and ever. It's going down forever and ever and ever. Does anyone know what's forever and ever and ever and ever and ever down? What number is that? Negative infinity, right? So it keeps going and going and going and going and going and going and going. If you were to trace it, you'd be tracing it for the rest of your life. So it actually goes all the way to negative infinity. Okay, let's see how high it goes. Well, it continues, keeps going. Oh, it keeps going higher, 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 higher. What's higher, 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 higher? Positive infinity. So if it covers everything, right, went from negative infinity all the way up to positive infinity, that's everything. What do we call everything in algebra? It's that funky looking R.
Real number.
Yeah. So we have y such that y belongs to real numbers. Y is an element of real numbers that belongs to real numbers. It's every single real number that you could think of. Y could be that.
Wait, how do you read it?
So this is, again, y with the vertical bar. And then we have y. And this is kind of a weird EC combo type thing. It means belongs to or is an element of. And it's just a capital R with a double bar. Double bar R. Yeah. Okay. So let's take a look at number 2. First, let's decide if it's a function. So you're going to take your pencil. I'm going to take my makeshift pencil here. And this is my graph, the like squiggle one. This is actually called the graph of sine of x. It's something you'll learn about in geometry. You'll learn about sine of x. You won't learn about the graph until much later. If you end up taking pre-calculus, that's when you learn about it. So this is actually a graph called sine of x. So as I go, notice it's only hitting once. Still only hitting once. Good, good, good. So notice it's only crossing the line once. And as I go along, it's hitting that purple line only one time, one time, one time, one time, one time, one time, one time. So that passed the vertical line test. So this is a function. Yes.
How do you do the domain?
Good question. So let's take a look at our domain. Again, our domain are x. See this arrow? That means it's going to keep doing that, bouncing back and forth. This arrow, it's going to keep doing that, bouncing back and forth. So what's all the way to the left over here? Negative infinity. Good. And it keeps going and going and going and going and going. What's all the way over here? So if we have everything, what do we call that? The weird R. So x such that x belongs to the weird R. And this is, again, x belongs to the real number system. It's every number in the real number system. Now the y is a little different. So again, y, I want to go from bottom to top. Where does my graph first start? Boop. What is that value right there? I think -3, right? See, the lowest point on my graph is at -3. Okay, so I start with -3. And then it keeps going, it has everything, and then what's the highest point on my graph? Positive 3, good. So it's everything in between -3 and positive. So I have it starts at -3, it stops at positive 3, y is everything in between. So we have less than or equal to, less than or equal to. So So when you think of your y's, you can think just the lowest point and the highest point on your graph. And if it goes on forever, that's what. All right, let's take a look at our next graph. All right, so our next graph. This is more like the type of graphs we'll be graphing in Algebra 1. You said it is a function. What? And Lindy says it's a function. My smartboard's not cooperating. Yep, it only hits it once every time. How about number 4? Is this a function?
No. Yes, in the middle of this.
In the middle, it's just sitting at that one point right there. It actually is a function. It actually is a function. So these are both functions. So let's just put our yes function. Yes function. Okay. So my domain. Oh, it goes forever to the left. It's going like this, so it's going forever to the left, forever to the right. See, it's going to the right and it's going up. It's going down and it's going left. It's doing everything. It's going forever to the left, forever to the right. That's all of our real numbers. And my lowest point on my y graph, there's the lowest point. It keeps going down. And it keeps going up. That's all my real numbers. And the super nice thing is that in Algebra 1, we're going to be backing these lines. And when it's a line, guess what your domain and your range is? All real numbers, all real numbers. Now number 4, this is actually, it looks like our cube root graph. So this is something that you'll graph in Algebra 2. This should have arrows on the end here. So go ahead and draw in the arrows there. It should have arrows. So what we have is that it's forever going, it's slowly going down, slowly going to the right. So it's slowly going, that's left. This is slowly going right and out. So we once again have all real numbers, yep. And same thing for y. So I'm going to show you a couple more examples of what's not a function. So we look for our lowest point. Our lowest point on the graph was these guys here. And the y value for that was negative. We don't have to write the repeats. Because that's the lowest y I have. And then my highest y I have is 3. So we have everything in between those. So y is everything in between. So y is everything in between. Okay guys, so a couple examples of not a function that we actually come across in math. There's something called a hyperbola. So you don't need to draw this. But we have something called a hyperbola in math. And it looks like this. This would be an example of not a function, right? If I were to, here's my arm going across. It hits it in more than one spot multiple times. That's not a function. There's also, well, we already did the sideways axis like that. We'll leave it like that. Okay, so that very last flap that says function notation, we're going to use that in class a couple days from now. So put on to that problem. We're just going to go and do some practice with functions. That's a great idea. Yeah, go put your names on the back of these so that it knows that we know. But keep in mind, these are part of your notebook. These are part of your notes, so don't lose them for that binder check.
I agree.
Yeah. And I feel it's an easy points grade, right? Because all you have to do is turn your papers that you've already done from class.
When do you grade that?
Usually after I get the test graded.
Oh, I think that'll be it.
Which
Almost a pick out.
Is it 7 or 8?
Stinger today.
7 or 8?
Yeah, stinger today.
What if you get
You're not gonna go to TA. On Monday, you're going to TA.
why?
Because that's just a rotation. So now how it goes is TA senior 1, next time is 6, 2, 3, next time is 4, 5, 6, then 8.
And then,
Oh, so
if you pass
every
it,
one we have to go.
TA and yeah, so today is senior 7, 8. Alright, so everyone should have gotten in front of them. Number 7, introduction to functions
Need another
practice.
one.
I wondered if I counted enough. Alright, so you're just deciding if it's a function, and then it says to give the domain range. Let's have you guys just do the, what do you guys want? The left column, the middle column, or the right column? Let's go middle. Middle sounds good. Let's just have you do the middle column.
Oh, let's do this.
I mean, you can pick whichever column you want. I just want you to get some practice in each. I think the middle works good. So go and try those 5, 8, and 11. Yeah, just do middle column.
We do 2 also.
Come on. Oh, I forgot 2 was above it. Yeah, sorry. Whoops. 2, 5, 8, 11. So the only unfortunate thing with these problems is that we have pictures and tables and graphs that take up so much more space.
What's the date October?
Oh, sorry, today's the 17th. And we try to throw in some SVOL type of questions where there's multiple choice. So like if you open up the paper, it's actually only 2 questions, but it takes up the entire page because there's so many pictures for it.
It should be our homework.
If only it were.
Honestly. Do we just write it's a function?
Yeah, you can just say yes or no.
You don't have to write out the domain and range.
Since it says to, yeah. I know. So feel free to work with those around you. Ask me questions. We're just gonna do some practice for our remaining time, and then at the end, I'll get you your homework.
Go for your spots.
And again, once you've done those ones, you can go and turn to the multiple choice inside and give those a try. I'm gonna do it for you. Graph. Yeah. Maybe your vertical line. Yeah. So
So you want to look for what's your smallest pi value, it's -1, and then the top you get here, which is so when you divide by the -1, once you do that. Yeah, so see how it has the arrows, I mean, it's going to keep doing that forever. So we have forever x, all your
All right, I'm going to go through and just go ahead and put up a few of these answers here. So you can go and check. I'm going to start off just with if it's a function or not. So we end up having the only one that's not a function in this column was number 5. And so if we take a look at it a little further, we can see 4 was repeated and it had different y values. And then our domain. So guys, you can even do, when you're doing your homework, you can just write D for domain. That's okay with me. My domain here would be 2, 3, 4, 5. What's my range for the very first one? Just 0. Yeah. Great. All right. Let me write one more, and I'll pass it to you. My domain here we had 4, 9, 13. Our range we had 0, 3. All right, so next class, we'll just be doing more practice with this. Bring this paper back. Number 7, we'll be doing more of it. If you don't have a video for the next class, it's just more practice of this. So you guys wanted the stapled one as your homework. I'm giving you the single page one as your homework.
You haven't put
37.
Seniors, please check in with your senior study teacher and report immediately to the school stadium for your senior signature. You will pick up your teacher before the picture.
No longer. The first thing one that's the same. No. Right, the schedule last year was different than this year. Yeah, but you guys have mentioned that you're getting fast.
That's 8.
8.
Just make 5.
Well, you don't have to walk as far. So number 8 is your homework, and we'll do more practice with this next class. Is there anyone that did not get a homework? Okay. Have a good day, Stinger 7 and Stinger 8. Stinger 7 and Stinger 8.